So we officially now are going to make the jump from Unit 6, where we had a little bit of the exponents there and brought them over, but now we're going to get into our new things here with graphing and some values a little bit. So we are going to be on page 1 of the Unit 7 note packet, since we knocked out page 0 already, which seems kind of strange. And so interval notation, as it says in the very top, good description, it's just a different way to write an inequality, to say if something's greater than or less than. And we've talked a little bit about that on graphs, but not as much in a math function like this. So similarly to when we were graphing these, we have got special symbols we're going to use depending on if there's a line underneath our greater than or our less than. So before we were playing the dotted dash game. Now the new game is, if it's just greater than or less than, we're going to use parentheses. And if it's or equal to with the line underneath, we're going to use a bracket when we're doing our graphing. So typically, we're going to use one of these two symbols on each end of what we're doing. So your beginning or end can be positive or negative infinity. Thank you. So I want to add a little piece to this, because positive infinity is going to be occurring when we're, oh gentlemen, this isn't how we get out of the destructive habits. And negative infinity is going to be as we're going to the left. So just a little extra hint in there to help us. And infinity just means we're going forever, sort of like Buzz Lightyear to infinity and beyond. So some examples of what we could do here, just to kind of help us out. So our first one is a compound inequality. There's two things going on. So I'm going to kind of work here in pieces. So if I were to look at this originally, let's say I cover up this 1 and this arrow, and I'm looking at this. So I'm going, okay, so I'm starting here at 4. X is less than or equal to 4. We can kind of follow the arrow with this a little bit. So when the arrow's pointing at X, that's less than. So actually, let's add one more little thing up here. So if the arrow's pointing at X, that's less than. Our arrow's going to be going left. And if the arrow is eating X, that's greater than. And that means our values are going to be going to the right, because they're getting bigger. So you're like, dang, Hardy, there's a lot of stuff to keep track of here already. We got symbols, we got arrows. That's why we're going to kind of work through several of these. So now that I've done that, let me cover this back up. So I look, I'm like, okay, so the arrow's pointing at X, that's less than. So in this case, okay, I'm going to be going left. I'm just going to make a little arrow there for the moment. And so if that was it, we'd play that through. But I also notice, I forgot one little piece. With the X is less than or equal to, we're always going to put a parenthesis or a bracket there, since it's got the line under. We're going to use the bracket. And yes, it matters. Okay. We're kind of communicating information with this. And so when I go to do the other one, and I cover up that piece, I got to be careful that I don't arrow follow here. Because I'm like, oh, so I start at 1, and I'm just going to go to the left. Well, no, I'm not, because the arrow is eating X. When the arrow eats X, that's greater than. It means we're going to be going to the right. But since there's no line underneath the arrow, I use a parenthesis for that. And I notice my two arrows are going to crash here in the middle. And you're like, wait a minute, that looks kind of familiar. We've looked at these before in this way with the graphing part. So when you see the compound inequality, we're just basically going to put symbols on the endpoints and color in between. That's where the answer is going to be. And so when I go to do the interval notation, that always gets done looking at my graph from left. Whoops, let me get that on the screen. From left to right. So, all I have to do here is say, okay, where's my graph start on the left? It starts at this parenthesis at 1. So, I put a parenthesis with 1, put a comma, and I start following it to the right until I run into my next point, which is at 4, and I put the same symbol that's there. That's interval notation. I'm done. These two things tell me the exact same thing. But as you get higher into upper level math, this is going to be the way it's going to look like most of the time. We're just kind of making that transition. So if there's two pieces, we can do it that way. If there's only one piece, we can still do that. So I look and I go, okay, first things first. Arrow's eating X. So which way is my arrow going to be going, to the right or the left? To the right. Because greater than goes to the right. So now that I've got my arrow, what symbol am I going to put on the 3? I'm going to put a parenthesis. Ooh, good question. So the question was, wait a minute. I thought this was open and closed circles. And the interesting part is, as you're doing your math, as you go along, it is up until about this point. When we start doing the interval notation, they want the symbols to match to kind of get some consistency to it. So we get rid of the circles, all the open and closed dots, and go to the parentheses and brackets. Good catch on that. So I got my graph done. Now I got to do the interval. Okay. We start on the left. There's my first thing I see is the parenthesis and the 3. Here comes my first introduction to infinity. If you have an arrow going either direction and it never stops, we're going to have infinity involved. Now the direction it's going matters. If I'm going to the right, the numbers are getting bigger and bigger and bigger. 3, 4, 5, 6, 7, 8, and it keeps going forever. So when the arrow's going to the right, we're going to use positive infinity. Kind of looks like a sideways 8 here. And infinity always uses a parenthesis. Never uses a bracket. Because it has no end. It just keeps going and going. So anytime we see arrows, arrows are infinities. Excuse me. And so you might catch on already to what this last one may look like. Because again, there's always 3 things I'm looking for. Number 1, which way is the arrow going? X is less than, it's pointing at X. Less than goes left. Okay, because of the line being underneath, I'm just going to kind of look line underneath, use a bracket, okay. Now, here comes the fun part. When we start to go left to right, this is the left, the arrow is. Arrows are infinity, but the arrow's going to the left arrows going to the left is negative infinity is our starting point. Does that matter? Yep.
Yes, it does, sir.
Positive and negative, it makes a lot of difference. Are we going to forever negativity or forever positivity? And so here's my left, and I'm coming to the right, and I run into -5 with a bracket. Those are the three options. There are no special cases or tricks or anything like that. It's just which way is the arrow going? If there's an arrow, there's an infinity. And watch for those starting symbols. Okay. Now we're going to take one more piece with this today. We're doing the line graphs up here with it, with interval notation. But that's also going to go with this spot down below. This is why I like to do these two lessons together. Domain and range with interval notation, okay? Domain is your x values.
What?
And when you do the interval notation of your domain, we work from left to right, least to greatest. And when we do our range, our y values, and again, that's the biggest thing with these. I just got to keep track of what variable it is. Your interval notation, you go from low to high, or bottom to top. And so when we're doing these, we're going to have infinities as well whenever there's arrows, okay? Arrows are always infinities, so that's what you're going to want to look for first. If it's a little dot, then we use numbers, but if it's an arrow, we use infinity. So I look at the first one. I can't really tell, but I'll kind of give you a heads up here. Those are arrows on both ends. So if I see arrows on both ends, domain says, what's going on from left to right? Well, that arrow tells me I'm going forever to the left. And as I follow my line to the right to see where it ends, I notice it's another arrow. It's just gonna keep going.
Infinity.
Lots of infinity. It goes forever and ever and ever. So arrows, you're like, man, arrows, we got lots of infinity. We do. Because when I do range from bottom to top, here's the bottom of my graph. But the bottom of my graph keeps going down forever. And as I go from the bottom and I'm working my way to the high part, it just keeps going.
So if it's just a diagonal arrow, it's going to be all infinities.
It's true. Whenever you see a regular old line with arrows on both ends, it's everything is infinity. Now, don't get sucked in, though, to thinking, oh, so if I see two arrows, everything's infinity every time. Not necessarily. Let me explain. I get to the middle one. Now, those are still arrows on both ends. So I look, and I'm like, well, okay, that's forever to the left, so that's still always infinity.
It's still to the right.
But it's still going to the right. So it's still infinity. You're like, Hardy, were you pulling our chain? Were you trying to suck us in here and fool us? No. When we get to range, okay. Remember, we're doing low to high. I see that it goes up forever.
But it doesn't go down.
It doesn't go down forever, though. It
zero?
stops
At -2.
right here, right. Wherever it stops, whatever that y value is where we go.
And now there's no more arrow. That's when it gets hard.
Okay. So just as a reminder, and this may be something that's good to do as you go. Maybe at the start, you may not need to do this forever, but maybe it would be a good idea as you're getting used to this,
The left is the left, and the right is the right.
is just to label some of these so you remember later, you're like, I don't understand where he's coming up with these things, and what's this whole, infinities and numbers and order. We've got it up there at the top, but if we actually put it on a couple of these, that could come in handy. But yeah, now comes the interesting part. What if there's not arrows? Okay? If there's not arrows, you will not have infinity. So this particular one, there's no infinity going on. Domain is your, yes, reminder, domain is our x's. So if I look at my point furthest to the left, follow it back to the x-axis, and that's where we start.
The other one is 6.
And if we go furthest to the right and follow it back to the x-axis, that's furthest to the right. And I just noticed I did something boneheaded. Oh dear. When it's closed dots at the end, this is on me. We're going to fix this now. Yeah, it stops. It's not going to, and I should have done that on my 2. I was so excited about getting away from infinity and getting to some numbers. I didn't put my bracket instead, because that's a definitive ending point. So again, left to right, so I can kind of see what's going on. Again, color's not a bad idea. When I go to do my range then, here's the bottom. But again, it's the y value that I'm looking for with range. So my bottom is at -3. And here's as high as we go. My top or my high, you can call it high, low, bottom, top, whatever you want to do. And I've got those endpoints. And you may run into some situations that you have an arrow and a point. We won't do anything different, but we'll take a peek at that here in a moment. But again, keep these somewhere safe. Find a folder. Find something where you're not going to misplace them, because having this can have some serious benefit when we get to our next quiz next week. Now, new packet. We're going to be on pages 1 and 2 today. A little bit of domain and range. So we're going to write the inequality in interval notation and graph the inequality. Okay. So I want to take a peek. Yeah, we got time. I want to take a peek at 3 of these with you. We're going to take a peek at 1 and 2 and 6. Method to the madness. So if it's just one number, we'll put our one number in here. We're going to keep this handy because we might need to reference some things here. So, okay, first things first. What direction's my arrow going to be going? Left, because we're less than. Okay, now, I'm glad that got mentioned. Well, Hardy, the arrow's pointing to the left in the problem, so I just go left. As long as your x is on the left, you can do that. But if x moves, that doesn't work every time. So don't get sucked into thinking I can just follow the arrow every time. Just be aware. Okay, so I got my arrow. What symbol am I putting on number 8?
Parenthesis.
Parenthesis, because it's just the less than. It's just the arrow, so we use the parenthesis. So get parenthesis, okay. So now our interval goes left to right, left, negative infinity, because if it goes left, negative infinity.
Please, is it a bracket when it's a number?
Okay, now on the, as far as the 8 goes, when I get to the right here, whatever symbol you used on the graph is the same symbol you're going to use here. If you used a bracket on the graph, use a bracket in the interval. If you use a parenthesis. The only one that we know every single time is going to be the same is infinity. Infinity is always a parenthesis. Every single time. Every single time, without exception. Yep, because infinity never has an ending spot. So as I take a peek at a couple of these others, again, don't get sucked in. Excuse me. So if I'm looking at these, let's say I look at this part first, and I go, okay, so at 3. Oh, what way? Okay, my arrow is pointing at X. I got my notes out. Arrows pointing at X is less than. Okay, so this goes left. What symbol am I putting on my 3?
Not a bracket. A bracket.
Bracket. Yep, we got the line under our bracket. And this is the part where we got to make sure, again, that we're not getting sucked into arrow following. We're not going left here. Okay? The arrow is eating X. Arrow eats X, that's greater than. No line underneath. We're using a parenthesis. So reminder, whenever you see the compound like this, it's just your endpoints in color in the middle. And then our interval, left, same symbol, no arrows, no infinity. To right, use that same symbol, and we're done. I want to make sure I pound home this don't arrow follow every time. That's why we're going to do 6. If I arrow followed, I'd go to the right. It wouldn't be right. The arrow is pointing at X. Arrow points at X. That's less than. Line underneath. And we're going left. Left, there's an arrow, which is negative infinity, because the numbers are getting less and less and less. To right. That's it. Okay? No crazy algebra to do yet.
Yeah.
We'll get to a point where we can get some algebra in here. Not yet. Not yet. We're taking our time. So we're going to knock those out, and then over on the back here. Okay. I'll flip it back over in just a sec here. Okay. When we're doing domain and range, if you don't see a very visible arrow, there's not one there. So let's say we're doing 10. So I'm just going to put little points on the end since there's not arrows. I want to make sure. So when I'm doing domain and range, okay. Let's see here. Let me do a little folding. Move this down a little so we got some help. Okay. So domain, we're looking for X values. So I want to see furthest left and furthest right. Just care about left and right with domain. Nope. Left and right. So I look and I go, okay, so like here's 0. So -1, -2, -3, -4. So -4 is furthest to the left. And we bracket it because it's not an arrow. And then if I go to the right, 1, 2, 3, 4. So it's just numbers. When it's not arrows, we use the number that's there. Now that one's pretty straightforward. Range is a little trickier. Because range now, so domain was X from left to right. Now range is Y from low to high. So I look, the bottom, right, it could be here, it could be here, it could be here. They're all at the same spot. They're all at Y equals 0. So I start with 0. The highest point looks like it's here or here. So 1, 2. Because again, I'm seeing how high it is on Y. Is the idea. So Y is lowest point, find the Y value. Highest point, still find the Y value. And we work it that way. But if, let's say, let's do one more. How about 17? We'll throw one in that's got a little of everything. So I look at 17, and I go, okay, I got this. X is left to right. So here's the furthest point left, but oh, there's an arrow on the furthest point to the left. So what's an arrow mean again? Infinity. But since it's left, it's negative infinity because it's getting small. The numbers are getting more and more negative as I go to the left. Find the furthest point to the right. Find the X value. Again, furthest to the right, keep reminding yourself it's always X when I'm dealing with domain. When I go to deal with range, that's Y values. I don't like using low to high. I'm going to use bottom to top because I think it makes more sense. So the bottom, the lowest point, is here again. Going down forever again. If it's an arrow, it's an infinity of some sort. But we don't go up forever. Here's my top point. That's as high as I go. And that Y value is 4. And we're set. So your job, if you choose to take it, because you want to be more successful or continue your success, is to play with these and get the practice now. Not the day of the test, not 5 minutes before the test, not after your parent threatens to ground you, but now so you've got it moving ahead. No more quizzes this week. Yeah, early next week. So I'm not 100% sure yet, but that's the game plan.